Good morning, everyone. My name is Hyun and our team name is JJABjo, as you can see here. I'm going to talk about measuring salinity, and these are our lovely team members. Here's our index. First, I will shortly express how and why do we have to measure salinity in the ocean, and then I will explain some methods for sea surface salinity detections. Lastly, I will take a close look at some salinities that measure salinity and short Q&As, of course. First of all, there are some reasons for measuring sea surface salinity, but they share same objectives: forecasting the weather and climatic changes. For example, an oceanic area with high precipitation, like equator or tropic region, there will be much more rainy days. So additional fresh water will be added during rainfall, forming a thin freshwater layer. This thin freshwater layer blocks heat exchanges or heat transportation between water and air. So it gradually influences the ENSO and monsoon. Another example for climatic change is taking place much higher latitude. We all know that thermohaline circulation starts at North Atlantic Ocean. During summer, sea ice starts melting and it creates tons of fresh water going down to the ocean. So cold fresh water would change the Gulf Stream, the hot current, to the ocean. So cold fresh water would change the Gulf, and it also affects on thermohaline circulation. In reality, Europe experienced greatest cold weather when the iceberg in the North Atlantic has melted more than average. I have prepared some pictures for better understanding. The picture looks a bit similar, but what is important is near Europe. During winter, we don't see any blue. We don't see any blue in here. Europe. But when it is during summer, we can easily see some blue areas or sky blue areas around Europe. So it definitely tells us that sea ice melting during summer has strong relationships on the oceanic salinity. Then what is the main mechanism to detect sea SSS from the space? Scientists use microwave radiometer and spectrometer for salinity measurement. For microradiometer, measuring microwave radiance from sea surface is key for finding salinity. Also, scientists use radio wave emitted from L-band in radio astronomy window for salinity estimation. Because this bandwidth is well researched for its special feature of not being affected by space or salinity intensity. On the other hand, we use emissivity for estimation if we use microwave. Emissivity means emission compared to black body surface at same temperature. For better understanding, some pictures are prepared. Pictures on the left is emission of black body. This one is black body, and picture on the right is emission of ordinary substance, which is for elastic. You can see every single emission from the satellite is absorbed and then emitted 100%, while only a certain percentage of the emission from the satellite is emitted again on the right side. Every substance has their own emissivity. For water, emissivity changes due to salinity changes. So if we know the temperature and emissivity of fresh water, we can roughly estimate the salinity. In experimental condition, 1 PSU changes means 0.5 K radiance changes. And this equation is Rayleigh-Jean equation. K stands for Boltzmann constant, lambda as you know, is frequency, and T pi means physical temperature. So if we know the temperature, we can get radiance of BF1. So then we compare this value with freshwater value in same temperature. We can estimate salinity by using difference in emissivity and relationship in salinity to emissivity. Sea surface emissivity is easily affected by not only salinity but also temperature, surface roughness, frequency, and polarization. Scientists use spectrometer for better correction. There are two satellites for measuring salinity. So one is SSS and other one is Aquarius. They both use L-band microwave micrometer. As you can see in here, SMOS stands for soil moisture and ocean salinity. It is low Earth orbit and it measures upright temperature by using microwave radiometer. And it needs very big antenna to make suitable resolution. And then most important thing for radiometer measuring system is collaboration. The most important, and we use two methods for calibration. One is noise injection, which is inject two different noises a few times to the system deviation stability. It is 757 km high in the air and sun-synchronous satellite, and its repeat cycle is 149 days. And SMS has partial resolution of 200 km and detects salinity differences up to 0.1 psu. Here are some pictures for SMOS. The last one is Aquarius. The objective for Aquarius is to monitor the seasonal interannual variation of the large-scale differences in the ocean. It also uses L-band radiometer and spectrometer instrument, and it locates 657 km above the sky, which is a bit lower than SMOS. It is also sun-synchronous polar orbit satellite. Aquarius measures salinity with a special partial resolution of 150 km and accuracy of 0.2 psu. And this is also a picture from Aquarius. Here, these are references.